Professor Hugh Durrant-White, it says you got your first degree in 1983, and you're in various fellowships and award-winning until, I think, yesterday you won something. It says here, his research work focuses on robotics and sensor networks. His work in applications includes automation in cargo handling, surface and underground mining, defence, unmanned flight vehicles, and autonomous subsea vehicles. You seem very well equipped to talk to the topic, the robots are coming. Please welcome Hugh Durrant-White.
So to quote the last speaker, I am the geek in the lab, okay? And it's my intention also to make sure that the camera operator at the end earns his keep by moving around the entire time. Look, I have a wonderful job. I build robots for a living. There's nothing cooler that you want to do, basically. Your work is actually far more interesting than going home, and that's part of the problem of being a geek. And I pulled up these things. These are some books I've got on my shelves and things like that. And you can see how robots have really been in the popular imagination for a long time. And actually, when I was putting these up, I was also looking at it and thinking, yeah, look, robots have actually got pretty good taste. You notice the women they're picking up here? That's one part of it. But also, I think the ladies out there need to be careful. If there ever was a robot invasion of the planet, do not wear a red dress, okay? Because that clearly is what's happening here. Look, my robots work better than this remote control, that's for sure. At the screen, good. Okay, so, one of the other nice things about doing robotics is you can actually sit around the lab watching old films and call it research. This is one of my favorites, the first one, of course, Metropolis, and this is Maria. This is people's conception of a robot. And I think I wanted to take home a couple of messages from these things. The first thing is the robot kind of looks like a human. And in fact, one of our fascinations with robots in general is that they're sort of human-like, but they're machines. They act in machine kinds of ways, and that's the way that we perceive robots. And you also notice the fashionable geek on the left here with the hair that hasn't been brushed. That's also the kind of model we take after as well. And I think the other thing you need to take home also about robot films is there's always some evil in it, right? Whether it's the robot that's evil or it's the robot designer that's evil, but nevertheless, except for C-3PO, who gets an honorable mention in this, okay, basically most robots are pretty evil. The other one I really like is this. This is Robbie, okay? Robbie from the Forbidden Planet, and I watch this every other week or so, okay? And the other interesting thing about what's interesting, again, that comes out when you talk about Robbie, you'll see that the robot scientist here has upped. He's got much more fashionable clothes now, and Robbie's got all these flashing lights, which is good when you're a robot. But what this is trying to show is that robots, we expect robots to do everything that we tell them to do regardless. I think in a minute you're going to see this guy and the disintegrator ray, and he's going to ask Robbie to basically walk into the disintegrator ray. So we kind of expect robots to do that. There's this kind of, machine-like thing that we're sort of interested in. But what I want to do today, unfortunately, is not talk about Hollywood. I want to talk, in fact, about reality, all right? Where are the robots? And it's pretty interesting because, I came to Australia 15 years ago, and Australia, as I guess you're all aware, is a big place, a long way from anywhere, that's mostly empty. And it actually turns out, unlike a lot of technologies, that Australia is actually the best place on the planet to do robotics, because it's big and empty and a long way from anywhere else. It has lots of great applications. We talk about in robotics dull, dirty, and dangerous, and there are lots of places out there where you can build robots that do dull, dirty, and dangerous things. In mining, underwater, materials handling, defense, agriculture, you name it. It turns out all the best applications for doing robotics are in Australia. And as a consequence, in the last 10, 15 years or so, Australia has now got into a position where it actually leads the development of robotics in all of these sort of outdoor areas. It really is pushing the boundaries, and there's more investment in robotics going on in Australia than there is probably in the rest of the world combined at this point, which is a somewhat amazing fact. So I'm going to kind of show you a few examples and give you a feeling for what these things are like. This is one of my well-known ones. This is actually the Port of Brisbane. Nobody works at the Port of Brisbane. Okay, these are all robots, okay, they all work together. All you have to do is to tell them where all the boxes are on a ship, okay, and it does all the rest. It moves them off, moves them around, puts them on lorries, kind of coordinates itself, optimizes the whole kind of thing, and so on and so forth. In fact, the only technical people involved in this terminal live in Sydney, not in Brisbane. Okay, so this is the kind of technology that is no longer just a science fiction thing. It's the kind of thing that's actually being, done for real because it actually has a valid use and so on. The other big area in Australia that we do a lot of work in is mining. There's a huge amount of investment currently going on in automating mining. So you take a big mine, this is West Angeles down here at the bottom. It's a big goethite iron ore mine, generates about 20 million tons of iron ore a year. It's full of lots of machines. It's 50 degrees centigrade in the summer, and you don't really want anyone to work there, so why don't you automate it? So there's been investment going in. If you go now to Perth, there's a building outside Perth Airport called ROC, the Remote Operations Centre. All of the East Pilbara mines are now operated from Perth. Okay? So this is an example, admittedly this is at the mine in this thing, of an automated drill. So this is a machine that comes along, drills holes. It's got to have some clever bits because every hole it drills has got to be slightly different from the last one, and so on and so forth, where you actually build up big pictures for what's going on in the mine. You drive 500-ton trucks without any drivers in. You do all these sorts of things. And mining's an obvious application to put robots into. You can just think about it. Not just on the surface, but of course underground as well, where you really do have issues with safety, with how you manage the whole process and so on. Here's another great application in Australia. Also wonderful for getting students because they get to spend all their time on the Barrier Reef. This is one of our underwater vehicles. It dives to about 1 kilometre deep, just to give you an idea. And of course, underwater, there's no maps like Google Maps. There's no GPS. So you've got to be really clever about how you use your sensors, build up that model, learn about what's going on in that environment, and use that to actually create data for scientists to understand what's happening with that reef, how it's growing, how it's losing stuff, or whatever else it may be. And you can do an awful lot. This vehicle we have here is probably offshore about 30 weeks of the year, to give you an idea, mapping different parts of Australia. And we provide information to scientists that say, not only here's your map, but here are the interesting bits. These are the bits that changed since last time you came here. So these are the things you need to worry about. You can almost imagine now you could have a network of these things all the way around Australia, just monitoring the coastline, ensuring everything's right, doing long-term climate change measurements, you name it. And you couldn't do it any other way except with a robot. Okay? Here's perhaps something slightly more controversial. We also do a lot of work in defence. Okay? Defence is a particularly one of these areas in which robotics, at least, you've seen people talk about robots in defence and this sort of thing. One of the big take-homes from defence, which I think it's important for people to understand, is actually, so far we're okay because they're not smart enough to figure out what to do with them. Okay? So you go to a defence guy, and although they talk about robots, there are no really clear applications for these sorts of things now, other than for basically surveillance or remote operation or these sorts of things. So this is our flight test facility. We own our own flight test facility just north of Canberra, and we fly all these unmanned aircraft of various descriptions. This is a very interesting project because actually we're flying lots of aircraft all at the same time. So they've all got to figure out how to cooperate with each other. And in fact, the problem in this case is the aircraft get a satellite image, and they know that there ought to be things in certain locations, so they start talking to each other, they start using their sensors to build up a picture and decide who should go and look at what different thing in the environment. So what's cool about this project, right, is once these aircraft are in the air, you have no idea what they're going to do. Okay? So you've really got to make sure that it doesn't run on Windows, because it's got to work, all right? Okay? And you've got to sort of answer all these sort of things. So there are lots of cool applications, but there are great outcomes for this in other areas. We're doing a lot of work now, for example, doing offshore surveillance, doing agriculture. We'll see the agriculture application in a minute, where UAVs can actually be used in many different places in Australia. Here's another cool example I like. So this is a startup company that recently came out of our lab, and these are sniper target robots. So basically, these are robots that run around a training facility. This is actually in Western Australia, and then people shoot them. Okay, so this is really good fun. This is much better than video games, okay? And when you shoot them, they basically, all the others run out of the way and behave like real people and everything else, so people can actually do the right sort of thing. And this startup company is well known in New South Wales now because it just won a $57 million contract to provide these to the US Marines as well. So there's sort of cool kinds of things you can do with this sort of stuff. And finally, because I know there are some people in the audience that have an art bent, we also have a resident artist in our lab who's funded by the Australian Council for the Arts, and we build robot sculptures. Okay? This is a sculpture known as Fish and Bird, and it's actually about a Greek love poem called Fish and Bird. Fish and bird fall in love, but they can never be together. And what happens in the robot thing is they kind of interact with people, they interact with each other, and then depending on what happens, they write different love messages to each other. All right? So it's really intriguing, actually, this one, because it's been on exhibit all over the world, and now we've got all these data sets about how people interact with robots. What do they do? And all this kind of thing. It's a really interesting kind of project. So, just to move on briefly here, one thing I want to point out to you is all the robots I showed you here didn't look like anything you saw in the Hollywood films, right? They didn't have 2 legs, they didn't have 2 arms, they didn't have a head or anything like that. And I think one thing that people forget is that actually a robot is not anything about what it looks like. A robot, what really makes a robot is essentially a brain. And what distinguishes this brain from any other brain, like the one in your iPhone, is that it interacts with the real world. All right? And it interacts through the world in two ways. It's got this perception pathway, what we talk of as perception. That is, it's got sensors. It's got cameras or infrared or radar or whatever else it is, and it basically looks at the world and it tries to build a model of the world inside so that it can understand what there is inside it. And this is where the true innovation in robotics is. How can I build in a computer a representation of this complex world? All right? How do I solve that problem? The second part of this is action. Once you've got this model, what do you do with it? All right? Do you move your arm? Do you push? Do you pull? Do you pick up a container? Do you fly in this direction? These sorts of things. How do you actually understand that process? And critically, what distinguishes a robot from anything else is the process of learning. Of learning. Good. Phew. And what this basically says is when I see something and I do something and it doesn't quite do what I think it should do, I will change my model. And I will refine my model. And I will add to that model. And I will learn in that process, that whole evolution. And learning is something that's critical to robotics. So you don't just get an algorithm that sits there and does the same thing every time. Every time it runs that drill, every time it drills a hole, it learns about drilling holes. It learns about drilling holes in other types of materials. Whatever that aircraft flies, it learns about what it should do the next time it does that sort of thing. It's this whole evolution process. And this is really the heart of what we're looking at in those Hollywood films. How does a robot actually go from just being a machine to something that's potentially intelligent? Okay? Let me focus a little bit on this. Actually, interestingly, this is what we use in our community as the definition of a robot, the connection of the intelligent connection of perception to action. Let me talk a little bit about learning here. So we often talk about in our lab trees. Trees are a very good example, and there's been an enormous intellectual paradigm shift probably in the last 5 years in robotics and machine learning and so on. We used to try and build models of things. We'd come up in your standard computer program, we'd build a model, say of a person, 2 arms, 2 legs, body, and so on. The problem is not everybody looks the same. And the worst example is a tree, right? Try and build a model of a tree. What does a tree look like? Is it tall, thin? Does it got bushes? Well, look at the one over there with the holes in, all right? So, you know, people used to try and build models. And as we've moved outside, our whole concept of these sorts of things has changed. And instead of being what we think of as model-driven, they're now data-driven. That is, the way what a tree looks like is as follows. I will take millions of pictures, and I will identify of those millions of pictures which ones are pictures of trees. And then I will say to the robot, those, they're called trees. Get it? So every time you see another image that looks like the pictures you've just taken that are trees, and clearly there are lots of mathematics involved in generalizing all this and everything else, then you will call that a tree. And then as you go through, you will learn about different types of trees, what they look like in the winter, what they look like in the summer, when they're covered in ferns and so on. But the point is it's data-driven. And what's intriguing is it's memory that's driving intelligence and not processing. You understand? It's all about how we associate those things. The other thing we talk a lot about in the lab is lemons. Lemons are really interesting. Because imagine you are a taste sensor. You have no other sensors other than taste. And you are only a sight sensor. You have no other sensors other than sight. Okay? And you only have smell sensing. Now I want you to have a conversation about lemons. All right? What do you see? What do you taste? What does it feel like even? Okay? And then in some sense, it's those mixtures of what you perceive that thing is that actually becomes a lemon. Do you see what I mean? And in fact now, if you think about it, the way I've explained that, if you now close your eyes and I give you the idea of a lemon, the way that you think about a lemon is the way it looks, the way it tastes, the way it feels. It's nothing to do with some geometric model or anything like that there is about a lemon. So we talk a lot about these sorts of things and how we build the mathematics and the algorithms that can replicate that process in a robot. So here are some little simple examples. So here's one of our agriculture ones. We've got this robot, this little helicopter you can see here. It'll fly along a farm and it will find specific types of weeds. And then it will spray them one by one. And you can program it to get to alligator weed, Sylvania weed, whatever you happen to want to destroy today, get them one by one. This is the sort of thing that you want to be able to do with these machine learning and recognition problems. Here is a second example in mining. So again, what we do in this case is we want to tell the excavator operator which is good ore, which is bad ore. And what we do is we just show them these are good examples, these are bad examples. Then you automatically go in this case using a hyperspectral sensor, special type of sensor, okay, and actually say those are the bits you want, those are the bits you don't want. You see what I mean? And you can go into any mine and do exactly that kind of operation. Let's see whether there's another one here. Yeah, this is a slightly more sophisticated one where we're actually looking at an urban platform. You can see this one at the top here. We're classifying not just one type of thing, but lots of types of things. Trees, buildings, people. And if you look at the video down there, there's a car actually driving along, not just breaking it up into different objects, but labeling them. So this one's a car, this one's a tree, this one's a pedestrian. Do you see what I mean? And it's basically learnt that by simply driving lots of streets. Okay, that's the way. It's a data-driven problem and not a model-based problem. So I want to move on and try and get to the next overhead. There we go. And talk a little bit about futures and consequences. So what about the future? I always think about robots where we are now. We're building the mainframe computers. Most of the robots I showed you there are millions of dollars worth, right? And that's why they work in applications like mining. But what about the future? Are you going to get them in your home? Well, this is some work of one of my colleagues in Germany, all right, which shows you the sort of thing that you can do. And this is now not just the sort of visual type of thing, but also the perceptual, you know, force, contact sensing, these sorts of things, how you can integrate. Again, you're not going to buy one of these in Harvey Norman, at least at the moment, all right, several $1 million worth in here. But it kind of shows you the integration of these different sensing, action, modalities. Requires enormous dexterity. In fact, when you think about doing this at home, the dexterity between lifting things up versus subtly turning things versus just putting just the right amount in the thing there, okay? You know, and also being able to pick up a thing. We're amazingly clever things, but interestingly, again, I think we've learned, you know, this data-driven approach typically is the way that you do it. You just make lots of cups of tea, and then you can make tea. That's how it works, all right? You know, I think that's an interesting insight. So here are some other futures which I think are interesting. Okay, there's a lady, my colleague in Japan. This is actually a robot, but it's a robot made in the model of his wife. I think it's a little odd, don't you? But nevertheless, and it's quite clever. It's got about 120 actuators in the face that can make the right facial expressions, smile, different sorts of things like that, and so on. But there are lots of other cool examples. Robot fish, robot dragonflies. You know, this is interesting over here. Robot crabs. My favorite down the bottom there, robot gecko. Okay, I can think of a lot of useful things to do with a robot gecko. So these are all possible futures. Okay, and I think perhaps one last potential robot future, if I can get this thing to go. Someone's going to have to replace the batteries in this. So here is, I guess, the other robot future that sometimes worries us, okay? We think a lot about this in the lab. Sometimes people don't give geeks the credit for thinking about these things. You know, we have philosophers come in and talk to us about evil and good and evil and these sorts of things, and it's very difficult when you're in any kind of science, whether it be physics or robotics or whatever. No matter what you do, it can be used for good things, and it can be used for bad things, all right? And in fact, you don't even get the choice. If I come up with a clever algorithm which can identify different types of weeds, someone's going to use it for identifying targets. You don't really have an alternative in this. And so we've got to manage the way that we think and the way that we deal about these sorts of things. So I'm going to kind of conclude here, if I can get this thing to work. There we go. So robotics. I hope I've shown you here that there are lots of robots out there, and in fact, a lot of them are in Australia. And, you know, there's been a lot of progress both in the last decade, but in the next decade, it really is going to be transformational. You're going to see essentially complete automation of the mining industry. You're going to see a lot of automation, semi-automation, partial automation of areas like agriculture, environment monitoring, and a whole range of other different things. And robotics has really moved now from being what I think of, or what I read as science fiction, to being a reality. Thank you.
Thank you, Hugh. Thank you very much. Fantastic. Apologies.